Now, for my presentation today, here is my module objectives. I'll be focusing more on the application or on the artificial intelligence version or side of natural language processing. This is because natural language processing also is overlapping to linguistics. So if you are also a bit of a if you are a major in English or if you are a major in any of the communications degree, some of the terminologies that we would be encountering here would be familiar to you. I mean, some of them has already been introduced to you by Dr. Pratik, such as the course of what is morphology, what is semantics, what is syntax. So these are even topics that we would also be discussing here. Now, having said that, here are the um, topics that I will be talking about. So first, I'll be discussing to you what is natural language processing in relationship to artificial intelligence, identify its different use cases in NLP, differentiate the two portions of NLP, which is NLG and NLU. So there is natural language generation and natural language understanding. From there, I'll also explain to you the pipeline on NLP because you'll notice that on the science itself, you need a way or you need to establish a process on how you would be able to break down together a simple sentence and then make the computer understand that sentence, right? So I'll be describing to you here the high-level pipeline or the different steps on how a computer model or an algorithm would go through in order to make sense of what human speech is. Okay. Then finally, I'll describe here what is a generative pre-trained transformer. And some of you may have already heard of this one lately. This is the GPT, right? So this is where your chat GPT, your Google Bard will be coming in. And although it is a monster on its own, no, I will also try my best to briefly discuss this to you so that you'll also understand how it works on the back end and how it is also related to AI in general. I'll enumerate also the different challenges faced by NLP because similar to other technologies, specific also to artificial intelligence and even to machine learning, it would also faces some challenges and complexities, no? Specifically more on how it handles and generates human language. Okay. And finally, briefly discuss to you or describe the applications of NLP to telecommunications and Open RAN in general. So you might be wondering, hey, we are in Open RAN, we are discussing or we are actually expecting more on the telecommunications aspect of Open RAN, but is there a relationship between NLP and Open RAN? How can we apply NLP, machine learning, and AI to telecommunications? So here I'll be proposing to you some three topics. There's some three key aspects that you might want to consider. Okay, now let's proceed. Now, what is natural language processing? So this one was described to you a while ago also. I'll give to you another definition. As what Dr. Pratik mentioned a while ago, NLP, like AI, has several definitions. No? But for this specific definition, NLP is a subfield of AI that deals with enabling computers to understand, manipulate, and even generate human language. Now, human language on its own is very complex. I mean, there are different ways on how you can express speech. There are different ways on how voice is expressed. And by that meaning, there is what you would call active and passive voice. There is more than one way to skin a cat, if you would refer to that. And that in itself is already also a complex sentence for a computer knowledge to understand. There is more than one way to skin a cat. If you are an English speaker or if you are familiar with idioms, you would know that definitely this is an idiomatic expression. So how is a computer able to understand an idiomatic expression? We literally do not skin a cat, right? But it means something else. So there is context being involved. Now, having said that, NLP utilizes advanced technologies, including computational linguistics, machine learning, deep learning models to process human language in various forms, from text to voice recordings. In terms of the science itself, no, there is also another field in computer science called computational linguistics, right? it is an overlap between linguistics and computer science, hence computational linguistics, right? Now, having said that, the goal of NLP-based solutions is not just to grasp the meaning of individual words, meaning you do not just take or parse out individual words from a given sentence, but also to understand and to comprehend the entire sentence as a whole, and even to understand the context of it. And not only that, but you also have to consider its intention and even its underlying emotion or sentiment. That is why um, you can say that NLP is an overlap between computer science and linguistics. Okay. And to be more specific than that, having already mentioned computational linguistics, you can say that NLP is more of like an applied science of computational linguistics. It is a field on its own that is tackling more on the example. If computational linguistics deals more on, say, the historical aspect of a certain language, how it has been structured out in terms of its syntax and semantics, how a given word is morphed and used already across the years. NLP deals more on how these theories can be applied to day-to-day use or even to use cases. So you can see that another simple analogy here is that if computational linguistics is more on like the computer science or pure sciences, NLP is more of like an applied science. So this is more of like already the application of what the theory is talking about or how we to make use of it. Okay. Now, NLP and its different subfields. Remember that in the previous sessions that we have conducted to you before, NLP is also a subset of AI. It's one of the many branches of AI, in fact. And you would see here that although it is considered as a branch, it also overlaps with other subfields, meaning that um, NLP can be applied using machine learning. And in fact, most of them do. GPT uses, which is a natural language processing use case. It is a chatbot, for instance, no? And it uses deep learning for it to gain understanding on the simple text that you type in its text field, right? But other than that, other systems and other applications can use NLP in conjunction with, for example, speech recognition and even computer vision. If you have or if you are familiar already with programming, it is possible for you to use NLP to make sense of what a computer sees through a webcam, for instance. So you can in fact interrelate them together, right? Now, NLP, much like other subfields of AI, often overlap in other subfields such as machine learning, speech recognition, and even computer vision. But if we're going to look at the practicability of NLP nowadays, normally we would consider NLP to be more associated to written text and its comprehension, understanding, and generation. That's why if we're going to look at it again in the form of another Venn diagram, so this is one great way in how we can express NLP. It is a subfield of AI, right? And it also overlaps with machine learning and deep learning, most of which deals with managing and manipulating data in the form of written text. But again, the caveat here is that it is not always limited to written text. It can even be through voice. Speech to text is also an example of where NLP can be applied to. Okay. Now, in terms of its use cases, I was able to find out three high-level categories on where and how we can apply NLP, and these are as follows. No? First one, the very obvious one, which is communication and interaction. We can use NLP as a means to enhance communication and user interaction, not just through human to machine, but also human to human or even machine to machine interaction. This is where majority of use cases, in fact, of NLP would fall in the form of your virtual assistants, in your chatbots, and even machine translation. More of these ones later when I go into detail. Another use case for this is content creation and automation. So if communication and interaction mostly deals with analyzing what a user has entered into, say, a given text or through a voice recording. Okay, content creation and automation deals with creating something based on that given text. So this is where your text filtering or would come in, right? For an example use case here would be, suppose say you can use NLP to gain understanding of a given email if that email contains certain words and those words are considered to be blacklisted. So that's already an example of email filtering or web filtering. Predictive text is also an example. So when you turn on predictive text into your smartphones, and you annoyingly sometimes have to disable it, especially if you're trying to type, say, Filipino, and the typed or the printed or entered text would be in English. Now sometimes it would also cause miscommunication. Predictive text can arguably be already considered as an application of NLP, right? Because the computer or the machine itself is trying to make sense of what the word you are trying to type to just by one or two characters alone, right? I mean, we are even just limiting this to languages that use the Latin alphabet. What more if, say, they are using, or for languages that use their other kinds of alphabets, like, for instance, Asian countries, such as in the likes of China or even in Japan. If you know how to write Japanese, you'll know how complex it is. All the more if you know how to write Chinese, right? This is also similar, or even in Korea or even in Thai, right? So it really depends, right? Now, and finally, and I would arguably say this is one of the use cases that is a bit more of a controversial aspect: content creation and generation. And by that I mean, through text alone, it's possible for you to generate images, and you just type a simple word phrase, generate an image for me that contains this, this, and that, and you'll notice that despite the image to be monstrously hideous, to say the least, no, at least the machine was able to comprehend what you are trying to type using just text alone. Okay, and lastly, the last use case for NLP would be information retrieval and analysis. No? There are also subfields or use cases where we can use NLP, some of which would include search engines, okay, text summarization, and finally sentiment analysis. So the first two you're already be familiar of, such as search engines and text summarization. In fact, you're using this one right now if you're trying to Google something in the internet, right? For summarization, this is most likely a tool used in the academe. There are already available applications right now wherein you just type in a simple text, and that text, you ask the model to summarize it, or you ask the AI application to summarize it, it would be able to provide to you a shorter version of that text, right? And finally, the last use case, sentiment analysis. This one is not as frequent or not as popular of a use case, but it is normally used in businesses. If you want to gain understanding of a given customer feedback or customer insight based on the reviews that they leave on a given website, you're able to quantify that given sentence and give it with a score. So that is sentiment analysis. You're trying to understand of the overall sentiment of a given review or a given text. You're able to quantify it, give it a certain number. More of this one later. Okay. Now, NLP often involves also several tasks. Okay, so here I was able to highlight three. First one, understanding. So through NLP, it equips computers and machines with the ability to process and comprehend the meaning of human language, including spoken and written text. Okay? So meaning through NLP, a machine is able to literally understand, and by that meaning make sense of what these words mean through its algorithms, through its processes inside, right? And in fact, when I how would a machine is able to break down a certain paragraph, for instance, a paragraph of text, and make sense on how um, that paragraph is structured out or its overall feel. No? I'll be discussing this one later when I go through the NLP pipeline. Next one, manipulation. It allows computers to or machines to modify and work with human language in various ways. This is where the use case of summarization would come in, right? Text summarization, wherein the computer is able to understand that, despite this 4+ paragraphs of words that this user is able to enter into my text field, I'm able to summarize it in, say, 1 to 2 blurbs or 1 to 2 sentences instead. So that is a form of manipulation. Okay. And lastly, generation. So it empowers computers to create human-like text or use text to create other forms of media or content, such as documents, images, and speech. Okay. Now, more of these three tasks. No? First off, in understanding. I've already mentioned this a while ago, sentiment analysis. So this involves identifying the emotional tone of a message, whether positive, negative, or neutral. Meaning, say, suppose me as a human being um, said something like, "This is fantastic. What an absolute bomb." Okay? I left this one, say, as a review, right? The system is able to understand that given statement and quantify it through the means of a score, right? Now, sentiment analysis also is another topic in itself. But in general, normally a given statement, after it has already been pre-processed and understood by the model in a way, you can use machine learning to implement sentiment analysis. Give it a score, and normally this score would range between 0 and 1. No? As a score reaches a value that is near or close to 1, it is more likely positive. It is if it is scores, say, more of like a 0. Sorry, the range is between -1 and 1. No? And so it actually varies based on the model that you use. But my point here is that you assign a score or a given value, whether is it positive, neutral, or negative. In my example here, it is overwhelmingly positive because the value is close to 1. If I say get a statement that is, "This sucks, I do not want to use this product ever again," then the chances are it would receive a negative score, right? If it's a value that approaches, say, 0, for instance, it is somewhat neutral. How the system is able to understand that? It uses the NLP pipeline. So later on, I'll explain. Next feature or next task is name entity recognition. So this is a feature that recognizes and classifies named entities within text. And these entities can be people, organizations, locations, places, pet names, proper nouns, etc. Okay, so one example of this one is that suppose I typed a model or I entered a sentence to a given model, an NER model at that. The model is able to distinguish the different important names within that given statement, and not only that, categorize them based on what they are. Right. So, for instance, here, Tesla last Monday announced it and revamped its top-selling Model Y electric car. It's able to get or retrieve Tesla last Monday and Model Y electric car to be organization, date, and product respectively. So this is one task. And finally, we have the more obvious one is machine translation. This is converting text from one language to another while preserving its meaning. So one thing fascinating about the human language is that um, there is definitely more than one way on how you can express something. And all the more if you try to express it in a different language, right? So in NLP, machine translation ensures that, say, I try to speak Japanese, Hajime mashite jon desu yo. The machine is able to properly translate it into English and say that, "Nice to meet you, my name is John." Right? So you notice that the use cases of NLP, although it's a new term, the use cases and the application that it already has right now, it's already there, right? It's just a matter of getting more familiar or getting acquainted to um, its specific use case in a way. Moving on. Another task that will involve is manipulation. So one feature of this is, of course, summarization, which is condensing large pieces of text into shorter summaries while still retaining key information. Now, you may have noticed also that there are already tools right now wherein you can use like summarization. So an example of which, if you are familiar with Quillbot, you may have heard of it. And Harry, you can even use ChatGPT or Gemini, Google Gemini, to summarize text, right? So that is one use case. No? Another use case is, of course, the very obvious one is question answering. I was able to find a tool normally used for the academia. It's called, I think, Chat PDF. So notice that the play word there. Where in this application, you get a PDF document of, say, a journal or a research paper. You upload it into your website, and the model is able to immediately grasp the keywords or understand the overall content of, say, an 8-page journal article. And from there, give you interaction in the form of a chatbot. In other words, you're able to technically ask the journal questions on what is it about, right? So extracting answers to questions posed in natural language from a given data set. So, but it doesn't have to be academic in nature. It can even be just as simple as a chatbot, wherein how does it generally work, right? You try to ask it with the questions. Say, for instance, here, who discovered gravity? We all know who this one is, right? But how is the machine able to understand this question? Well, it can refer to a body of knowledge, a document, websites, a compilation of information, and this is what you would call a corpus, right? In Latin, this is body in short, or if you're going to put it into our context, a body of knowledge, which is then used by the model to immediately get answers from, and from there provide an appropriate answer. Okay. Now, another feature is paraphrasing, wherein the machine is able to restate the meaning of a sentence or passage using different words or sentences. So again, this can also, or majority of the use cases or tools that I was able to find here is inclining more on the academic side, meaning that these are tools that can make academic work such as research, reading, synthesis, review of related literature much easier, right? And not only that, you can even make fun or use it just for fun. Like for instance, when you're trying to say something like, "Oh, who y'all messing around right now, my homies?" Um, I'm not sure if you are familiar with this accent, but this is a bit of an American, right? And from there, the model is able to understand it right and properly give to you the meaning of what that sentence is, right? So what are you doing with your friends today? So it's able to paraphrase what I said into a different way or express it into a different way. And lastly, we have generation. So here, really, the chatbot would shine. So this is where simulating conversations with humans such as us would definitely come in. Generation or chatbots fall into generation. This is because the models themselves, the GPTs, in fact, are able to generate text based on a given prompt, right? But you'll notice that it's not purely for generation alone. It would also involve analysis and understanding. Another example for generation is machine writing. Okay? So an example of which would be text prompts for a generative AI. So meaning you prompt that AI model to say generate an image for this. But if I were to make a much more fitting example of say machine writing, you can use AI to generate code if you are a programmer or a developer. So for instance, you can just type a prompt here, write a Python code for displaying the text in hello world. And from there, the model is able to provide to you the corresponding syntax for that given instruction. So in a way, you are feeding instructions to a machine and it's able to generate source code or programs for you. And lastly, text-to-speech analysis. It's a bit of in my opinion, a bit of a questionable movement for large companies such as the likes of Apple, Google, and Alexa. And when AI really took its turn in the early 2020s, no, you may have noticed that they went a bit on the backside, right? You may have noticed that it is ChatGPT who is taking the spotlight. But in a way, they are already there in the form of text-to-speech synthesis. I mean, just by saying, "Hey Siri," no, it's able to, or your phone, if you have an iPhone or an Apple device, it's able to immediately detect the voice recognition and um, sentence. I'm trying to also prevent this one also from saying this is because I have my Apple device and it would activate, but still, you get the point here, no? Another example here is Alexa, wherein you try to say, "Hey Alexa," and immediately the device would be able to detect your voice, right? So this is text-to-speech analysis. It is able to convert my voice, which is something that's audible or in audio form, make sense of it, translate it into text, and from there, trigger the machine to get my attention. Okay, so these are three of the high level use cases that you would have, but you may have noticed that all of them share some same functionalities and characteristics, right? This is where the two major components of NLP would come in. Okay, now NLP as a study or as a science consists of two components: natural language understanding and natural language generation. So you may have noticed some overlaps between the two, right? Now, first off, natural language understanding or NLU, what is it? This is a subset of NLP which uses syntactic and semantic analysis of text and speech to determine the meaning of a sentence. It focuses more on machine reading comprehension, or how the machine is able to understand and interpret the human language. So for my example here, let's say, well, majority of us are using English, so I'll use English as a language, no? Let's take one simple word. Okay? Let's take, say, the word key. In Filipino, it is susi. Okay? Key. It means a lot, right? I mean, for us, in the Filipino language, the word key can be a noun, which means susi. It can also mean important. Okay. It can also mean another thing. In a key, I'll show it to you, right? So in a way, for example, in this sentence, I suppose anybody here who is familiar with D&D, Dungeons and Dragons, so that is a tabletop game. So let's put this one into context, for instance, and say you are in a campaign right now, and this is what the dungeon master is saying. So first off, the key to the castle has been lost. So you'll notice the word here, key, it is used as a noun, right? But then he goes on and says that the general played a key role in making the campaign a success. So notice that the word key is still there, but how is it being used? Is it still being used as a noun? Of course not. It is already being used as an adjective to describe another noun, which is role, right? And then he then further goes on to say that the guardsman locked the door, keying it shut. So what does that even mean? I mean, if you're going to look at it from these three examples alone, you're able to see and understand that, hey, the word key here means a lot of things, right? And it is now the role of the model, of your AI module through NLU to make comprehension on these three words and how they are used based on their context, right? So a bit of linguistics 101 here, no? So you may have seen here the key terms, key here, pun intended, um, syntactics or syntax and semantics, okay? So when we say, or when we refer to syntax, it refers to how a word is structured out, right? While in semantics, you just refer to the underlying meaning of that given word. By the way, I'm not a linguist, so that's my caveat there. But my point here, just in this simple example, the word key, you need to understand how it is spelled. Okay, that is where syntax would come in, and how it is used in a sentence. That is where semantics would come in. So notice that just by these three simple examples alone, through NLU, makes sense of how the word is used in these three sentences. And that is how NLU is in general. Okay. Now, the other component of natural language processing is NLG, or natural language generation. So this is a subset of NLP which involves producing a human language text response based on some data input. So meaning input is still being needed, and you'll notice how it overlaps with understanding because it involves the analysis of said input. It focuses more on text planning, sentence planning, and finally realization. So let's take an example. For instance, suppose you use a chat GPT or Gemini, former Google Bard. You type it with a simple statement, say, write me a simple sentence. Right? And from there, you're able to see something like an ellipsis wherein the chatbot is perceived to be thinking of a good answer for your simple instruction. But on the back of it, it's already going through the NLG process of immediately planning out a given text or a given sentence for it. It's also able to identify the different words that it would be able to use, and finally make it a realization wherein it would use a reference, say the corpus or the body of knowledge that it contains, in order to create a simple text. So this is where NLG would come in. And of course, there are a lot of nuances to this, but you get the point here of what NLG is. Right? Now, before we can move on further, let's have a quick recap of what machine learning is about. You'll know now that in NLP, this is a subset of AI, and we can actually use machine learning as a means of implementing natural language processing. But for those of you who haven't yet been able to attend in the previous sessions, so I've just quickly spun up these slides that I was able to present a while ago. So we know previously that AI, this is a science that deals with creating intelligent machines that is capable to mimic perceived human intelligence. And a subset of it would be machine learning. Okay, now, machine learning, this is a subset of AI that deals with the creation of models. And these models depend on data, and from that data, make other data or draw a conclusion out of it, or to gain insight out of it, without explicit programming. This is unlike your procedural programming wherein you have a simple if then else. It is very structured. A machine learning uses a model, and that model, through a series of mathematical and statistical computations, able to give out a result. Okay. Now, a subset of the subset is deep learning. So this is an example also of machine learning wherein you use neural networks to make sense of the data, and how the model is structured. It is akin to, say, an artificial neural network wherein you have several hidden layers before it reaches an end result. Okay? Now, this is especially important for ChatGPT or for GPT in general, because GPT uses a transformation or a transformer architecture, okay, which is implementation of deep learning. So more of that one later when I discuss what GPT is. Now, because machine learning depends on data, a workflow on data science and engineering is needed to ensure that the created model will produce the correct and desired result. So my point here is that is NLP somewhat also different to machine learning? Well, it can be, but most of the use cases that we have nowadays, it still involves the creation of an NLP model, a language model. that is able to get data from users in the form of written text. So it still goes through the same workflow as how you would be able to, say, example, create a linear regression traffic trend based on a table of values. The only difference here is that the input is already human text. But regardless of which, it still uses the machine, or you can use the machine lifecycle model in order to implement NLP. Okay? Now, having said that, allow me now to introduce to you the NLP pipeline in AI. So I say here pipeline, it's because data in the form of text, no, is considered to be unstructured data. Even though it is written in a paragraph form, no, it is written in text, no, it is treated by the machine to be unstructured data. And by that meaning that it's just a blurb of text for it. We might be able to make sense of it because, hey, we know what we wrote down, but how is the machine or how is the model able to understand what we have written? So this is where the pipeline would come in. And the steps in general would consist of several steps. Now, based on my research, I was able to find out that most of the pipelines that are currently being used nowadays, although here we have 7, we only have 5 most important steps to take. This is not to say that the other 2 can be dismissed. No, it just says here that most of the references that I was able to get here refer to these 5 basic steps to be the foundation of an NLP pipeline, meaning that this is what a pipeline would consist of, right? Now, in some sources, these are the basic steps in NLP, but again, how the pipeline is implemented, you can use machine learning model lifecycle in order to process the given unstructured text. Okay, so we have here 7 general steps. So I'll go through them one by one. First one, sentence segmentation. So these are the questions that were raised in your Kahoot this morning. So first off, sentence segmentation. So as the name implies, so this step divides the entire paragraph into different sentences for better understanding. So if I were to take English as an example, we can use the period here to be as a delimiter between the different texts found in a given paragraph. So suppose I was able to take this example paragraph from, say, Wikipedia. By the way, the steps I was able to find here, what I'm referring to is the general steps found in this source. So I'll just give credit where credit is due here, as well as the example that was given there. You can locate this one up. Notice that I have here a series of paragraphs involved. Sentence segmentation, as the name implies, just means chopping down the entire paragraph into smaller text. Now, this would differ depending on how a sentence is broken in a given language, right? So for us, English speaking, and in fact, some also Western and a few Eastern languages use the period as a means to delimitate a given sentence. There are some languages that use other symbols for them to separate a given sentence. And it doesn't have to even be a period. It can even be a question mark or an exclamation point, right? If you say know how to speak Spanish, or you know a bit on, or some of the Spanish languages, say Spanish speaking countries such as Spain, Brazil, no, Mexico, for instance, you may have noticed that in their exclamation point or even in their question marks, they use not just the symbol for question mark or the exclamation point only. Normally, they would also place it at the very beginning, but in an upside down form, right? So that is also where sentence segmentation would come in immediately telling the model that, hey, this is only the certain part of a certain sentence, whether it is it declarative, in an inquiry, or an exclamation. Okay, but here we just used a period for this example. Okay, so after a sentence has already been broken down, then the obvious step is to break down the sentence into smaller phrases. Take note, I use here phrases, and that more technical term for this are tokens. So this is where the next step would come in, tokenization. So tokenization breaks the sentence into separate words or tokens. This helps understand the context of the text even more. When tokenizing the sentence, it is broken into separate words or phrases based on the model's set threshold. Depending on the model or on the language model that you want to refer, a token can be within a sentence, separated with spaces. It can even be symbols. It can even be the characters themselves, right? So comparing again English, it is easy for us to understand that a word is also a token. But take note that not always the case. Sometimes some tokens can even consist of several English words put together as one. Okay? If I'm going to take here an example of another language, say Japan or even China, wherein each word can be tokenized into a specific symbol, no? Then those words can be expressed as one word. So this is especially nuanced in Chinese and in Japanese language. For example, the word sushi, if you are to translate this into its kanji form in Japanese, no, it consists of two characters, su and shi. If you are going to take it from in the word itself, sushi, we know that it is a food, we know that it is a Japanese dish. But if you're going to break it, or if you're going to tokenize it based on its character symbols, su and shi, you would get a different meaning for it. Right? So that is where tokenization is also important, wherein you set a specific threshold for it. Is a token equivalent to one word? Is it equivalent to only letters? Is it equivalent to characters or phrases? It still depends. Okay? Now, after we have tokenized a given sentence, in my example here, no, the next step would now involve stemming. Now, stemming and the next step of it, which is lemmatization, are somewhat a bit of a confusing step. I mean, for one, I'm also confused when I first heard these two terms. But here's how you would simplify it. Stemming helps in preprocessing text. It is a means to normalize words based on their base or root form. In other words, it helps to predict the parts of speech of each token. Okay? Now, suppose now I have a given text, London. Okay? So, its obvious base form is also London. So that is its stem, right? Well, actually, no, if you're going to look at it, no, you can, if you're going to refer to stemming, right, you can even split London into two words, lon and don, which can even mean different things. Lon can mean the abbreviation of longitude, and don can mean to don or to wear, right? In stemming, you just take that given token and just break it based on also not just the word itself, but even the surrounding tokens with it. Okay, this token is then fed into a part of speech prediction model, and it's able to identify what kind of stem is it. Is it a proper noun? Is it a verb? Is it a conjunction? Okay, a determinant. Okay, so taking my example a while ago, you then give each token an assigned role in its sentence, wherein it can then be given whether is it a proper noun, a conjunction, or an adverb. Okay, this is also the step wherein if there are some words that would say are what you would call this combined to other prefixes or suffixes, no? Stemming is able to cut out those prefixes or suffixes and just take the base form of it. So, for example, eating, we know that eating, if it goes through the stemming process, it can split it into eat and ing, and then disregard ing altogether. We just take the eat part. Okay, so if stemming is more of like taking the base or root form, lemmatization. So one thing to also consider here for stemming, this also considers understanding the basic syntax of a given word. We know how London is spelled, right? So in lemmatization, it removes inflectional prefixes or suffixes and returns the canonical word of the canonical form of a word. So if stemming is to the base or root form, lemmatization is the canonical form. So just to give you an example, let's take the word again for London, right? In lemmatization, it is incorrect to say that the lemma of London is Don or even Lon, right? Because we know that London, its lemma is also London. We know it to be a word or a name of a place, right? So its correct lemma is London. Let's take another word or another token, say capital. Lemmatization, take note, doesn't just mean taking out any prefixes or suffixes. It can also mean the underlying or taking the, again, the semantics or how the context of that word is being used in the sentence. So, capital as a word has different definitions, right? I mean, it can even refer, it can be a noun or it can even be an adverb. But if we're going to take the context of the sentence on how, on the example sentence that I have shown a while ago, we definitely do not want the lemma of capital to be associated to be the adjective form of capital, which can mean the best or the top or supervisor. So we do not want the lemma of capital to be the adjective form. Instead, we want it to be the noun form. Okay? Now, notice also that capital as a noun can also mean different things, right? In a business context, capital can mean asset, it can mean money, but in the government or political context, it can mean metropolis or municipality. So in lemmatization, you also have to consider this. You don't need the word or the context of capital to be referred to as a business terminology. We want it in our sentence to be referred to the political definition of what a capital is, meaning it is a city, it is a metropolis, a municipality, it is a means of delineation of a given group of people or houses. So this is how lemmatization is being applied to. It refers to the context as well on how the word is being used. Now, you'll notice that up to this point as well, majority of the steps that has gone through mostly involves taking the user input and essentially breaking it down into its smaller, most constituent points. Now, this is because you'll notice also that the process itself really does, well, it makes sense that you have to first break it down into its smallest, most unit piece of data before you can even analyze it, right? And that is also where lemmatization would where arguably be the last point on where you break down the sentence into its smallest, most understandable units, right? Or the lemma. Now, the next step would now involve filtering out those small chunks or small tokens. No? This is now where stop word analysis would come in. So this is the process of identifying and removing commonly used words with little meaning on their own. Now, this is not to say that we remove everything completely, but the purpose, or this is just a way for the model or for the machine to make sense of which are the more important parts of your data set or of your sentence. Okay, so the process of analysis of SWE, stop word analysis, is removing most of them, conjunctions, prepositions, and articles of language such as the, in, and, of, etc. Right? Now take note that not all of the stop words have to be filtered out. Okay, again, similar to how tokenization would come in, a threshold is also set. Just to give you a classic example, we consider our country alone. Do we say Philippines? whenever a country say um, uses the word Philippines, it is normally not referred to just as Philippines. The Philippines normally. So the there is an example of a stop word. But when you try to tokenize it, you do not remove the you do not filter out the word the in the Philippines. So that's an example. Or another example here would be in some, if we're going to look at it from an academic perspective, you do not say just China, okay? You say the People's Republic of China, right? It's a full word or it's a full term, the People's Republic of China. Okay, some countries might even include the word of in their word itself, right? Or some also countries or some models would in fact even filter out some words that are also significant to the name of a country. Like for instance, South Korea, North Korea. You do not filter out the word South or North. Okay? In states, you do not just filter out North and South Dakota. You still include the word North and South, right? So it still depends, but the point here, and take note that just because we filter out something doesn't mean that we remove it completely from the sentence. It's just a means for the model to understand which are the more important parts of that given sentence. So if I were to say, take again my example here a while ago, we now know that after this sentence has gone through SWA, we now make sense now that most of the important words here are London, capital, most populous city, England, United Kingdom. Okay, so that is SWA is being used. The next one is dependency parsing. So how does it work? Now, after filtering out the most important words needed for that sentence, the next step is now to find out how the words are associated with each other. And the model would normally use a tree form or a logical structure in order to correlate the different words and how they are being used in a sentence. Now, algorithmically speaking, or coming from a algorithms perspective, computer science perspective, no? You take normally a root word that would serve as your parent word, and from there, branch out to other words associated to it. So if I were to take again my example a while ago, let's take any random word. Example is. Okay. Take note, is also a stop word analysis, but for this specific process, because it has already been word or considered to be a stop word, no? Regardless, it is still considered as part of the sentence itself, but it is just a reference point. And from there, understand how is the word is associated to London? How is it also associated to capital? Okay, so we know that is a verb of the word be of nor the present tense of the be verb, and it is connected to London in order to describe it as a proper noun, right? And it is also connected to capital, wherein capital is also a noun. So London is capital. So you'll notice there that it is trying to describe London to be another form of a noun, right? Which is a capital. Make sense? So from there, no, apart from that, you also need to understand or through dependency parsing, make sense of how other stop words are also associated to the main important words themselves. So taking here the example of capital, we know that it is connected to the word the and the word the end. We know that the word the is the determiner and the end is the conjunction. Okay, and since the word end is also connected to another word, no, but it is mostly associated to end the city and the most popular city. Back to my sentence a while ago, it's not connecting to end anymore, but it is more of referring to the word capital, and the capital is connected by end, connected to city. So it's a bit confusing at first, but my point here is that through dependency parsing, you're now able to associate the different words and how they are now connected with each other. Okay. The last step is the part of speech tagging. This is where mm, your language or your English proficiency, if this is if we're trying to parse out an English language, right, or the English language itself, this is where your part of speech will come in. This is also the step wherein you assign now the different roles in a given word based on how it is used in a sentence, considering also the grammar. Okay? So in a while back, no, part of more description here, part of speech tagging is the process of assigning grammatical labels or tags to each word in a sentence. Right? This is different from stemming. So you'll notice that we know that London is a proper noun, right? But in part of speech, we know that um, London is also your subject. So adding that subject in London is where the part of speech tagging would come in. So these tags correspond to the word's function within the sentence. If stemming more is related more on what the word is about, part of speech tagging is more of like how the word is used in the sentence. So what I tell you, NLP is also a linguistics 101 course. Okay, so such as the noun, the verb, the adverb, adjective, and so on. Okay, this is also important, especially for this part, because not all of the languages that we have nowadays follow the typical SVO or subject verb object structure. It still depends, in fact, right? So in my example here a while ago, using that same example, we now know that the word London, not only is it also a proper noun, but it is also assigned as a subject. Okay, we know now also that the word is also assigned as a word to be, which is an attribute associated to capital, which is also a noun. Okay, which is in a way also your object, right? So again, it also depends on the language that is being parsed on, right? Because in some examples, right, I know a bit of Japanese here, so I know that the word or the structure of the Japanese grammar or the Japanese language is not subject, verb, object. It's more of like subject, object, verb. So it's different. So if I were to say the cat is eating, so notice that the cat is eating, subject, object, verb. That is how it is spelled out in English. In Japanese, it would say neko ga tabemasu. So neko ni wo tabemasu. So it is structured out differently compared to English. You also have to consider in the part of speech as well the different voices on whether is it active or is it passive. So this is also where its proper tagging would also be given. Okay, so even though my apologies there, we also already also tackled a bit of linguistics there, but again, NLP here it's somewhat related. So I hope you're able to understand here. But again, out of the 7, the most core basic steps that you have to only consider are the 5 ones. So let me go here. Let me show it here again. So it is this one, right? So these 5. Okay. But again, if you want to consider also NLP across several sentences, you can include the first one. Now, in some references also, dependency parsing is associated to be part of speech, right? So it is also merged along with the functionality of part of speech. Okay? But in the reference I was able to find, it is considered as a separate step. Okay. Now, moving on. Having said that, no. Now, because NLP goes through several steps all at once, you now understand the overall complexity on how it works, no? And implementing this in the form of a language model is a challenge already on its own. But having said that, it is not nearly impossible because we already have GPTs in play. Okay, now what is GPT first? No? GPT stands for generative pre-trained transformers. And this is a prominent framework within generative artificial intelligence, and it falls under the umbrella term of large language models. Now, most of the items or most of the topics that I have discussed here applies more on the machine learning aspect of natural language processing. If we're going to look at NLP on a much bigger picture in relation to machine learning, there are what you would also call large language models. Now, what are these in general? LLMs, in a way, are models specific for a language, right? So meaning it is an application already of machine learning, and based on whatever functionality that you want to use on how you can analyze or generate text, you use an LLM. And on the underlying aspect of the LLM is where GPT works alongside LLM. It is a use case of LLM. Okay. Now, how it is implemented, they are essentially neural networks. So you associate deep learning already with GPT, and they are designed for natural language processing tasks. In the table that I am showing to you here, these are just some high-level examples. Now, the one that you are seeing in most websites or in the internet nowadays, these are what you would call your chatbots, right? So this is more of like in a developer perspective, this is your front end. This is the component responsible for interacting with the end user. It's the chatbot, which is a separate system on its own. Behind this chatbot is your LLM or your large language model. This is where GPT would come in. Okay, so for my IT or for my developers out there, you may have also be familiar with how a system would be structured out. You have a front end, you have a logic, and you also have a back end, right? So the frontier here would serve as your chatbot or your customer or end user facing. The logic here is the LLM or the large language model. So this is responsible for manipulating and processing the data itself in the form of language text. And finally, you can have also the backend. The backend can be the database. It can even be the corpus or the compilation of different knowledge bodies now used to refer to by the LLM in order to generate and understand text. Now, based on the company who developed the LLM, the most popular one nowadays is, of course, the GPT LLM model, which one was developed by OpenAI. Okay, and their front end is, of course, obviously, ChatGPT. The versions of GPT nowadays is based on the corpus it refers to, right? If I'm not mistaken, I think GPT 3.5 refers to a corpus or a data set from the internet coming back as early as 2011, if I'm not mistaken. Now, I'll have to check my reference here, my references then. But my point here is that versions of GPTs or LLMs in general would normally refer to up to what extent of body of knowledge is the LLM being referred to. Okay, at least for the case of GPT. Okay, for Google, for Meta, Meta even is developing already their own LLM models. No, it also varies. Okay, so from my personal experience, most of the use cases that I have used, I'm more of akin to using Google Bard and also to Palm because frankly that's the one that I have at the moment. No, but there, Bard is using Palm 2. Okay, nowadays it is also using the Gemini LLM. Okay, and in fact, I believe Google has already combined Gemini to be both the chatbot itself as well as the LLM, if I'm not mistaken. Okay, because they also have another product there called Vertex AI. But my point here is that the GPT itself, it's called GPT because of several aspects, okay, or several characteristics. Now, a GPT it's named as such because of, again, generative, meaning it is, as the name suggests, excels at creating novel content. Now, this is a bit of a double-edged sword. Okay, now the pre-training model phase equips them with the ability to predict the next word in a sequence, allowing them to create human-like text formats from poems to code and even in images. So that is where the concept of generative would come in. Pre-trained means that because it is a large language model, unlike similar models that you have to train and develop on your own, they already come pre-bundled, meaning that they already know that if they receive this kind of text, they know how to respond to it. It's just a matter of how you can optimize it. Okay? And finally, the transformer aspect relies on the third one, which is the neural network architecture. A bit of a technical aspect here, no? The transformer architecture actually consists of two components. You have the encoder part and you also have the decoder part. Okay. If I were to simplify the terms here, no, the GPT is structured in a way that tokens are fed into the decoder and it is further transformed into a data set that can then be referred to back using the pre-trained model. Okay, so that you can even further look one up. What is the transformer architecture? This is one of the uh, milestones or the key points of artificial intelligence, specifically for machine learning. Okay, but the point here is that GPT, it has key characteristics. Again, generative capabilities. It is already pre-trained in the form of a large language model. And the transformer architecture type or it is implemented using neural networks. Okay? Specifically the transformer architecture. I'm not kidding. It is really called the transformer architecture. Okay, so there. Now, similar to other technologies related to AI, NLP also faces several challenges. Now, I was able to find a good source for this meta dialogue. Now, you can even look this one up. The website itself cites 7 challenges, but I was able to congest it into just 3. Okay, so what are the high-level challenges? Number 1, ambiguity and vagueness. Okay? We know how vague the human language is. I mean, it's not just in Filipino, it's not just in English, right? The word yarn, okay, lately that has already been gaining popularity. You know, if the if if a chatbot is able to see the word yarn, it's not able to distinguish it to be a ball of thread, right? So that is already one challenge. The uh, NLP is already facing. So human language is often filled with words or phrases that may mean a variety of things depending on the context, right? To accurately analyze and interpret the intended meaning, NLP algorithms must detect the context in which the word or phrase is being used. So for instance, you say, well, you're already familiar with ChatGPT, right? So when you try to type a simple prompt like, generate this for me, okay, so definitely the machine would also respond to you. What does this stand for? What are you referring to? Right? Are you referring to generate an image, generate text? So the sentence itself, generate this for me, is already vague. You do not, or it's if say you open the session and you just type this one on its own, it would ask you for more context, right? Because it needs clarity on the question that you have typed. Okay. And sometimes you would also be flabbergasted on what you would have to type next. So that's one challenge, ambiguity and vagueness. Another challenge is language transition. It is challenging for natural language processing systems to stay current and handle new language advances appropriately. It is challenging to keep up with the developments in NLP algorithms, must constantly update their language models. Again, language models are not on itself self-growing in a way that they create ideas out of thin air. Well, technically they do, but they refer to something else, right? So meaning it still refers to a database. The model still refers to a body of knowledge. It still refers to files or contents. And if these files have not yet been updated, then of course, the model itself would also respond with an outdated answer. So for example, if you try to type there, what is goat? I'm not sure if you're familiar also with goat, no? Definitely, the chatbot would respond to you by saying that this is a four-legged domestic animal, but no, you're actually referring to the goat, GOAT. Okay, so anybody here who knows the word, the acronym code, no? Or of course, this is a more recent term, a more recent word, which can mean an acronym for greatest of all time, right? So it varies, no? And let's take it also in Filipino, the one that I have given example a while ago. Okay. In gay lingo, the word yarn does not mean the ball of thread, right? So it can mean a different word for us, right? Okay. So, or the word sana all, no? And sometimes the word sana all can even be expressed or spelled out in a different way, right? And having said that, the third item is figures of speech. The word or the term sana all is actually a figure of speech, which is a bit of a tone for sarcasm. And this is also a challenge faced by NLP, right? Figures of speech such as sarcasm, irony, and idiomatic expressions are definitely a stumbling block for NLPs. These challenges can lead to NLP systems misinterpreting the sentiment of a text, mistranslating languages, or failing to accurately answer questions that rely on understanding figurative language. If I were to take a more wholesome example, for instance, this item is a bomb, and you try to apply sentiment analysis to it. Right? So, what a bomb? So, if you may have heard of that as an English term, um, the sentence or the model might misinterpret it to be something else, right? So in my example here, she's cold with her words today. So it's a bit of it's a figure of speech, right? It's a metaphor, right? But again, if the model is not trained properly, it might respond with a different case. No, maybe I check her temperature today, and then you would respond with face palm, and then the bot would say, "Do you have a headache?" Then so here sometimes no chatbots is not yet in that state of um, taking figures of speech in a way that would say be just an exclamation, for instance, of the user. Okay, so yun. So that's it, no? Although we still have challenges, of course, this also gives us a more of a realistic picture on where we are right now in terms of availability of use cases, specifically for NLP. Now, having said that, no, after talking to you in more than an hour already on what NLP is, right? I mean, what is machine learning, what is artificial intelligence? And you are enrolled in Asia Open RAN, but why are we even talking about NLP and Open RAN in the first place, right? So here's what I propose. NLP and its application to Open RAN. You may have noticed that majority of the discussions that we have right now primarily circles. Yes, we have artificial intelligence at play here, but the application of AI through NLP primarily focuses more on parsing text, right? For making sense of the human language. How does now Open RAN play here? Or in a much more bigger picture, how can I relate NLP with telecommunications, right? Here's what I propose. Now. In the telecommunications space, the one that I am also exposed of, are also dealing with human interaction, right? Human to machine communication plays also an important role in telecommunications in general. It's a bit of an irony if telecommunications being a field dealing with communications does not have a means for their underlying business processes to make communication more efficient. Okay? And that's where NLP can be a possible use case. Now, I was able to propose here 3 high-level use cases on where NLP can be applied in Open RAN in general. No? And this can be applied across the different domains of your telecom. right? From access up to core and even to services. But I'll start off with the most obvious one, which is in your end user space. Chatbots and virtual assistants. I mean, you are already familiar with Ask G, right? In Globe, right? So that is an example of a virtual assistant or a chatbot. Oftentimes, with mixed reviews, if I would say, NLP can allow telecommunication companies to develop chatbots that can answer customer questions, troubleshoot problems, and even take orders. Now, I'll have a bit of a caveat here also. Having been experienced being in the telco business myself. Um, Although there are industries that are already pushing towards the use of chatbots in virtual assistants in their specific line of field, having experienced it also myself, it still pays that it has its place in the business, right? This is just an opinion, by the way. Um, but it cannot completely replace human interaction, right? If there are certain use cases that are specifically nuanced to a given issue, not all can be answered by a chatbot, but there is a use case for it, right? At least there is a use case for it. So that's one. Another one, the one that is not really much too obvious nowadays, especially if you are in the network aspect or in the technical aspect, no? Network operations and maintenance. While most operations and monitoring systems are point and click based, NLPs with AI may also be used for providing contextual instructions for a specific process. So if I were to put it in um, more niche perspective or niche use case, no? Intelligent controllers nowadays can even incorporate NLP as part of already instructing the machine in order to perform a certain task. Instead of just, I heard this term in a training that I had recently, the word click ops, wherein instructions are just point and click. No? Nowadays, all you have to do is to even just type out the entire instruction, and from there, the network is able to identify what specific steps it has to go through to perform a given configuration. So think of it like ChatGPT, but in the network. Okay, so that is how one possible use case would come in. And lastly is cybersecurity. So NLP, this is more of like applied also in the network, but more of on the filtering aspect of it. NLP can be a tool to enhance cybersecurity by understanding and analyzing communication patterns such as access level phishing, detection, spam filtering, and even insider threat detection. Now, one thing great about large language models is that you don't necessarily also have to program the models to understand human language. It can even be made to understand machine language or even machine configurations, right? It's also a language, right? The programming language, C or Python or even Java, no? Although they are considered to be programming languages, they are meant to be read by humans so that they can be developed accordingly. Because in the computer sense, the only language that they can understand are machine language, which is just a series of ones and zeros in binary. So arguably, you can also incorporate machine level or programming language code as a part of filtering out any possible threats found inside the network. That's also one use case for it. Unless, of course, you know how to read binary, and you are definitely the GOAT because you know how to read machine binary directly. But I digress. So there, so you have three possible use cases, no? Um, that's it. So in summary, NLP in general, it is still a continuous field of AI that also continues to be developed and improved on. No? Despite of it offering several of its advantages, its benefits, its features and use cases, it also still imposes several limitations on how it can be used, not just in Asia Open RAN, not just in telecommunications, but in even day-to-day living. Okay, there are several aspects of it. There are several processes that you have to go through. And you also have to understand that NLP is not an isolated science on its own. Remember that NLP deals with the human language. So definitely, you also have to tackle here a bit of linguistics as well. And like what I have said, computational linguistics.